Hi friends, welcome to Pareto analysis series of FRM Part 1, where we are checking all the important concepts of FRM Part 1. So this is the second part of this series. In the first part, we mainly covered reading number 1 to reading number 6, that is the probability till hypothesis testing, the first 6 readings of quant section. Now in this second part of this series, we will finish complete quant. So we'll start with reading number 7, linear regression, and we will cover it till the last topic. Last topic is your simulation and bootstrapping. So I will tell you like what are the important areas, what type of questions to expect from particular reading and everything. So the complete guidance will be provided in this video. So if you like this type of videos, so then make sure you like, subscribe, and share it with your friends. And again, so in the next part, the third part will be on the book number 3. Okay, so I will upload that as well. So let's start with the first linear regression, and for this we will definitely use Falcon and Defense notes, which are the best notes for FRM Part 1 preparation. And in case you are getting that doubt like why I'm saying the best notes, whatever you are using right now, check those notes versus just you will be able to see it on the screen, the Falcon's notes, and you will see huge gap in those notes. Okay, so that's why Falcon notes are the best notes for the FRM Part 1 preparation, specifically if you are taking the or going for the self study. Right, so we are starting with the reading number 7, linear regression. So this reading starts with the understanding of linear regression. So what is a linear regression and all? So linear regression is a very basic equation where we have like say y is equal to alpha plus beta multiplied by x. I hope you have already studied this particular topic, so you know already like what is a linear regression, what is a linear regression equation with one variable. The first part covers the one variable part. Now this particular reading starts with the introduction of linear regression. Here we are only discussing what is linear regression with the example. Then next is the steps in the linear regression. Again, this particular part is for your understanding, not directly testable. Then steps in linear regression. So again, these are the steps in linear regression. So you can check these steps and just understand the basic meaning of it. I don't think like you will get any question on this particular part, but you should know this because this is like important area from your understanding standpoint. So if you understand this particular part, then it will help you in understanding the further portion. Now, next is very important area from the exam perspective, which is a linear versus non-linear regression equation. What makes any equation a linear equation or non-linear equation? The differentiation is very important. GAP likes to test this particular area again and again in the examination. So make sure you understand very clear difference between the linear and the non-linear. What makes any equation linear or non-linear? Now here we discussed like the equation, the basic equation. So y is equal to alpha plus beta multiplied by x plus error term. Now here we have y and x. So y is determined and x is the independent variable, which is the observed variable where you have to provide any input. Now we need to worry about two factors, so alpha and beta. And the question is how to calculate alpha and beta. For this we discuss or the most common used method for calculation of the alpha and beta. See, there are other methods as well for the calculation of the alpha and beta, but we are mainly focused on, or we mainly discuss the ordinary least square method. So OLS method for calculating or estimating, the right word is estimating alpha and beta. So this is the equation and this is the calculation. We'll start with the calculation. Okay, so this is just a visualization. First, this is the case, like whatever we are using. So this is, we are trying to estimate the daily sales based on the independent variable, which is the YouTube ads. So assume like Falcon and Defense, we use YouTube ads and how YouTube ads impact sales. So we want to understand like what is the impact of YouTube ads on our sales. So this is the basic illustration which we are using for the understanding and visualization of the data. So this is for your understanding, not from the exam perspective, like not important for exam. But again, whenever I say not important for exam, that doesn't mean you should not study it. You should study it equally, okay? But you have to like make sure whatever I'm saying, like this is the important area, in that area you have to put more emphasis at the time of revision or at the time of preparation or whatever is at whatever stage you are on. So you have to focus on that. Now the parameter estimation. So this is how we can we estimate the parameter. So this is a calculation part. Calculation part is important, but here I provided the detailed calculation. Detailed calculation as in how we reach till this beta. So remember in equation y is equal to alpha plus beta multiplied by x. In the first step, we estimate beta and not the alpha. So first we will estimate beta. So beta is simply covariance of xy divided by variance of x, or this is the second alternate formula. So first you must remember this particular formula. If GAP provides you information relating to this formula, then you will need to like you will need this particular formula, you will need support of this formula. Then next is the step-by-step calculation. This is a step-by-step approach for the calculation of beta. But remember, in exam, you don't have to bother about these steps. Okay. So if you are provided with X and Y values, and maybe like say GAP asks you to calculate the alpha and the beta part, then you can do this with the help of TIBA2 plus calculate directly. You don't have to follow all these steps. These steps are to provide you just an understanding of how things work behind the calculator. Right. So first we will get the beta, where we are using the covariance of xy and the variance of xy. Covariance and variance are coming from this particular table, and simply we have like this particular solution, and this is our beta. So we will use this particular beta in the calculation of intercept, that is the alpha, and here you need the average of x, average of y, and the beta, and you can easily get the intercept here. So once you get the intercept, you will get our equation, and this equation is the sales is equal to your alpha plus beta multiplied by x. X here is YouTube ads. This is the first part, and you must know this particular part because again, this is GAP's favorite area. GAP likes to test this particular portion in a way, like I'll just provide the basic information like alpha and beta may be provided, and you'll be asked to calculate, say what is the impact of on y if the x is xyz, whatever it is. Now, second scenario is GAP will provide the basic information to calculate beta, that is the covariance, variance, and or correlation like that, and then the enough information to calculate the intercept. Then your steps are first calculate beta, then calculate intercept, and then provide the equation. So this will be the equation. Maybe the equations will be provided in your options and like that. So these are the type of questions which will be asked. Again, one more thing, don't think about like the GAP asks very difficult question in the exam on the regression or any other topics after hypothesis testing. GAP asks generally very basic questions on this area. The problem is students don't understand concepts properly, and that's why they make mistake in these areas, right? So we have to focus mainly on all the basic concepts. You must know each and every basic concept by heart. Okay, that's the condition here if you want to score really good in the quant section. Next is the calculation of the error term. You remember we saw this particular equation where our equation is alpha plus beta, y is equal to alpha plus beta multiplied by x plus error term. Now, what is that error term and how it's calculated? So this is the error term and sum of squared error. So here we will discuss like what is error term and how it is calculated. Again, this table is for your understanding, not testable in exam. GAP is not going to ask you like to complete the table because yours is the objective exam. Now here, this is how you calculate the error term. So remember and understand, and you should be able to interpret the error term. So what is the meaning of error term? Now next is the most important area again in this chapter, which is the R square, the explained versus the unexplained variance in the regression. So this is kind of important for the understanding perspective, but not very important from the exam perspective. Okay, so this is the important area. So total variance is TSS, ESS, RSS. Understand what is the difference between TSS, ESS, and the RSS. Then measure of fit R square, how R square is calculated. So ESS divided by TSS, 1 minus RSS divided by TSS, and like that. So this is a formula for the R square calculation. Here you have to understand two important points. First, how to calculate the R square. Second, how to interpret the R square. What is the meaning of R square? And this will decide, like GAP might ask you a theoretical question based on this, your understanding of R square or the interpretation of the R square, right? Next is the dummy variable. So this is a basic concept of dummy variable. So what is dummy variable and how it works? So here the most important area is how many dummy variables you need for a specific scenario. Then we have properties of OLS estimator, super important. And you must remember each and every property, like you must understand each and every property by heart. You must, there is no like escape from it. Then properties of OLS estimator and their sampling distribution, very basic discussion, just read it once. Then hypothesis testing. Again, you have to understand what is the hypothesis testing, how it works. Mainly, we are mainly concerned with, in the regression chapter, we are mainly concerned with all these rules. Okay, so you have to understand it, but our main focus will be on the rules. What are the rules? And GAP might ask you any numerical question where you are supposed to answer like complete data will be provided to you, and you have to simply tell like, is this like the coefficients are statistically significant or not, or like say B1 is statistically significant or not. Remember, there is no as such hypothesis testing for intercept because intercept doesn't affect our calculation, the total calculation, or it doesn't affect our forecasting ability of our equation. So that's why generally intercepts are not tested, only the coefficients are tested for the hypothesis testing. This is again the setup, which is also called as this is ANOVA table. And you might see ANOVA table in your examination, and where You are supposed to understand, interpret the ANOVA table, and based on that, you have to answer some questions. Very, very important area. Make sure you understand ANOVA table. ANOVA table is nothing but whatever information we calculated above are presented here. Okay, so and all the important information is marked in a red format for linear regression. If you are in the linear regression with one variable, if you are in linear regression with multiple variables, in that case, you have to also consider this adjusted R square. Moving on to the next chapter, which is the reading number 8, regression with the multiple explanatory variables. Again, this is very interesting reading. So we're starting with the basic equation setup. Now, the assumptions in linear regression with multiple regressor. So I provided all the assumptions here only and here. So the assumption is the first multiple regressor model. This assumption is applicable for the multiple regression, and all the other remaining assumptions are applicable for both the models, both as in the one variable or multiple variables. You must remember all these assumptions. You must understand all the assumptions, like what's the meaning of a particular assumption and so on. Very important area. Now, interpretation of regression coefficients and why regression coefficients in the multiple variable model are called as partial regression coefficients. Very important discussion. You must know like why it is called as partial regression coefficient, and this is the explanation of it, that why it is called as like partial regression coefficient. Now here we are using the example. In the multiple regression, we are using example of same example, but the extended example. Now the intercept is again our cells, which we saw in the first chapter. But here we are using the example of YouTube ads, Facebook ads, and newspaper ads, where I'm trying to identify like how YouTube ads, newspaper ads, and Facebook ads impact our sales. And this is our regression equation now. So we have three explanatory variables, and our dependent variable is the y, which is our sales. So again, this is your model, and then interpretation. Very, very important. This particular part is very important, like from exam standpoint. Now, goodness of fit measure. So this is a goodness of fit measure. Understand what is the goodness of fit. Then standard error of regression. Previously, if you consider like exams before 2020, this particular part, SCR part, was kind of GARP's favorite area. Now, in recent exams, I don't think like GARP tested this SCR or like that. I don't have enough information about it. But the problem is like, because this was an important area, GARP might ask you again, like what type of, like what is a SCR? What type of, like what can be, what is the formula for the SCR, or calculation of the SCR, or what is the meaning of SCR, and so on. Okay. So make sure you understand it. Next is the adjusted R square. Now, adjusted R square is again most important area. Understand what is adjusted R square, understand how to calculate the adjusted R square. You must know how to calculate the adjusted R square. Second, third. Just a second. Okay. So yeah. So first is the understanding of adjusted R square. Second, calculation of the adjusted R square. And third is all the like interpretation meaning of adjusted R square. And yeah, this particular part. So can adjusted R square and R square be negative? Very important area. So you must understand and everything. And here I extended this adjusted R square discussion. So you get like, you are able to focus enough, or you specifically understand how adjusted R square works. So this is a very detailed example where we are individually adding one variable at a time, and how it impacts your adjusted R square and how it impacts the R square. So you will be able to understand this particular concept in a proper manner. Next is the joint hypothesis testing and the confidence intervals and all. So this particular part is like a theoretical discussion. Understand what is the joint hypothesis testing, why it is done, and like how it's done. Again, don't worry about the, like, you should not be worried about the calculation method. If you can do all the calculations, then definitely you should, but don't bother about it if you find this particular part, the calculation part, very difficult. You must remember or know all these like criterias or the rules to check if the slope or the beta coefficient is statistically significant or not. Okay, next, joint hypothesis testing of two, like this is where like we use the F distribution. Again, I don't think, like from the exam standpoint, I don't consider this as very important, but we don't know. Next is the reading number 9, which is regression diagnostics. Very important reading. Again, because the exam is theoretical now, so we should be like, we should focus more on the theoretical type of chapters, where this particular chapter is kind of theoretical chapter where you have a lot of things which can be tested in the examination, and we have added like a lot of questions on this area in the like our question bank or the mock test. Now here, this reading starts with the assumption and related concept. So first, what are the assumptions? what are the violations, and what concept relates to those assumptions. So regression diagnostics mainly checks like, is a regression model violating our assumptions of the regression model? That's the discussion here. So we will discuss multicollinearity, heteroscedasticity, Cook's measure, and the omitted variable bias. And you have to read each and everything from this particular chapter. We'll specifically tell you like what is the like understand, and you have to remember, you have to understand each and everything from this chapter because everything is super testable. Okay, then bias variance trade-off is there. Again, important area is marked in red. This graph is, or this particular what is like figure is very important. It will show you you have to understand what is the general to specific model or m-fold cross validation model. Very important. You have to understand like what are the steps in each of these models. Then comes the heteroscedasticity. Understand the difference between the homoscedasticity and heteroscedasticity and the graph for it. Effects of heteroscedasticity, detection of heteroscedasticity, problem with heteroscedasticity, and solution. So I provided each and everything in this particular manner, so you get the proper understanding. Instead of mixing each and every text with each other, I provided solutions like this, and again, this is the testable area. Okay. So then approaches to modeling the heteroscedasticity. So these are the 3 approaches you have to understand and read from this. Now, multicollinearity. Multicollinearity is again the next discussion. What is multicollinearity? Identifying multicollinearity, solution to multicollinearity, and then there is a VIF. Understand what is VIF and how you can calculate it. This is very easy calculation and how the VIF rule is applied. So understand this. Then the residual plot visualization is one more measure, just theoretical discussion. Outliers testing. This is how you test the outliers, which is using the Cook's ratio. Okay, so just read it. Again, there is basic rule. You have to calculate D, and if the D is greater than 1 and like that. Now here, you don't have to worry about this particular formula because again, GAP is not going to like, again, this is based on my assumption. Like GAP is not going to ask direct question on Cook's measure calculation because the calculation is slightly complicated. You cannot use directly calculator and requires a lot of time to calculate. And that's the reason why GAP might not ask you a question on this. Then comes the OAS estimator, is the best linear unbiased estimator. So this particular area paragraph is very important from the theory exam standpoint. Now we are coming into the reading number 10 and 11, which are on the time series section. So first is the stationary time series, second is non-stationary time series. Again, for my students or anyone who is using Falcon's books, one disclaimer. Now here, understand one thing. So I personally think like the books, the main curriculum books are written in very complicated manner, okay, which makes understanding from those books very difficult. Second, in order to simplify it, I have to tone down the language of that discussion. Okay, so what I did here, but in that process, what happened? I extended this discussion. And generally, in the area like stationary time series and non-stationary time series, GAP likes to ask specific to the point question. Okay. Now the problem is because I extended this discussion, you will be able to understand things in a better manner. But remember, you must remember the key points to make sure you tick right answer in the examination. Okay, so definitely GAP is not going to ask question which is like perform time series analysis. Okay, so that's not possible in the examination. So what GAP can do is GAP can ask you the specific to the point question, right? So that's the possibility in this chapter. So the problem with this is like I extended this discussion and now you have to look for the specific points. If you're taking classes, I already told you like what are the specific points which are highly testable and like that. But if you're using only notes, then just try to remember each and everything, or there is second solution. I created this particular mind map. This mind map provides like this 2 pages provides all the important points which are testable. So you should use first the reading notes completely, understand each and everything in detail. But definitely you should also use this mind map to make sure you remember all the important points. So full notes plus this particular mind map so that you don't like you don't lose on all the important concepts. So our discussion starts with the time series introduction. Now this is like the cross-sectional data versus time series data. This starts with the time series data. So this is how the time series looks. Now what are the components of time series? Again, understand this, like if you consider the GAP's notes versus my notes, so my writing is slightly different or the more different. And one more thing I would like to tell you here. If you know how to perform time series in Excel, even if you are my student and you already watched the video which are on the time series regression in Excel, I'm not providing it currently. I have like it is hidden. Okay, you won't be able to see it till your exam is over. There is very specific reason for this. Now understand one thing. Time series, if you check say 10 different authors, every author writes time series or provides time series explanations in a very different manner. And if you consider these 10 authors, and if you see how it's done practically with the help of R programming, Python programming, or the Excel, it is done completely differently. Okay, so the concepts are same, but we perform it in very different manner. Okay, so the steps are not the same as it is written in the books or the academic books. If you know already like how time series works, then you will face a lot of problem in the examination, because GAP wants you to answer whatever is written in GAP's book, okay, or in a GAP's manner. Okay, so that's the problem. I made sure like whatever is given in the GAP's curriculum, it is covered in the book in that language only, in that language as in that flow only. I didn't change the flow, I just toned down the language. Okay, that's the only difference. So avoid applying your practical knowledge of time series in examination. Hold it for some time, just prepare it like an academic book, and then once you're done with the examination, you can check for the if you're a student, then you can check for the time series videos. So now here, so components of time series: trend, seasonality, and then random variable noise. This is how it works. So our observation xt is the outcome of xt as in x in time, okay, point in time. So x is the observation of trend plus seasonality plus random white noise. And this is our normal time series. This is second time series. So these are two time series here. So now how it works. So this is the first overall trend. This is we are using or analyzing the UK gas consumption. Overall trend. Now we can separate trend from the complete time series. This is like only trend. Then we have separated trend from the time series. So from this particular time series, simply separate the trend, remove the trend. So you will get this type of graph. Again, if you remove seasonality, so this is the only seasonality. If you remove all the components, then you get the random white noise. So everything is explained in very proper manner. So for your understanding purpose. And now from here, your actual discussion, the GAP style discussion starts. That is, what is a covariant stationary time series? Again, you have to remember what is covariant stationary, what is not covariant stationary, and you must like remember all the points here. The next is the stochastic process. Understand, remember what is a stochastic process, how to model the stochastic process, which is using the AR model or the MA model. Okay, then there is a white noise process. Understand what is white noise, what is the meaning of white noise, and so on. So all these are the properties of white noise. What is a Gaussian white noise and how it differs from the normal white noise. And then there is a Waltz theorem. Understand it, what is Waltz theorem. Then there is a lag operator. Understand what is a lag operator. Again, this discussion is very important. Then autocovariance and the autocorrelation function, very important, but this particular formula is not very important. Okay, so I don't think like ARP will ask you to calculate any autocorrelation or the correlation, autocovariance or the autocorrelation function in the examination. Now next particular part is the ACF and PACF, partial autocorrelation function. Again, very important area. You have to understand like when to use ACF, when to use PACF, how ACF works, how PACF works, what is the meaning of ACF and meaning of PACF. And then this is your ACF and PACF different diagrams for the same time series. Okay, so I have to remember this. Then how AR model works, the basics of AR model, ARP process, basics of ARP process. Again, everything will be tested on the basic level. Then you'll work a equation. Again, understand the basics of it, moving average, how it works, the basics of it. And then there is a differentiation of the AR model, MA model, and ACF and PACF. This table is very important from the exam standpoint. Now the auto-regressive moving average, ARMA model. So what is the ARMA model, how we combine it, and why AR model should be used in any calculation. So that's a discussion here. Then the sample autocorrelation. Again, so this all the discussion is kind of a important discussion. You have to understand all the theory perspective, like from the exam perspective, remember the important points. Sample autocorrelation function. Now here, understand what is the sample autocorrelation, and then joint test of autocorrelations. So this is joint test. Again, understand the basics of it. Don't try to remember all the formulas and all. Okay, so if you can remember it, but from the exam standpoint, it's not important. Then model building and selection criteria, very important. BIC, AIC, when to use BIC, when to use AIC, what are the advantages and disadvantages of the BIC and AIC, and how it affects the calculations, final results for the final decision-making process. Then Box-Jenkins model, Box-Jenkins process. So understand it, what is it and how it works. Seasonality. Now again, the basics of seasonality, because seasonality is covered in the next chapter, not here. This is the discussion, basic discussion of the seasonality. So I combined seasonality discussion in the next chapter, which is the reading number 11, which is on non-stationary time series. Moving on, the non-stationary time series starts with the trend estimation. So again, understand the basics of it. Seasonality, understand the basics of it, how it works, what are the important areas. Seasonality is model using the dummy variables, and this is how its model works. Then forecasting with the time series and the trends. So this is the, like, you have to understand and remember it. This is your forecasted model. Understand what is HTV, trading day variation, and holiday variations and everything. This is for the H type ahead forecast. Random walk and the unit root test, unit root process. Very difficult discussion, even from the pure academic standpoint, but from the real applicability, like the real life perspective, it is very easy. So random walk unit root, you need to understand all the basics of it, understand, and then the challenges in modeling unit root. So these are the challenges. Dickey-Fuller test, understand what is Dickey-Fuller test, and just that's it. Okay, understand it. The next is the measuring returns and volatility and the correlation. Again, if I don't remember, like if I already told you or not, so understand one thing. Time series is difficult on the academic level, on the theory level, but it is very, very easy from real life perspective. If you want to apply time series model, it is very easy. It is not that difficult, and it is way easier compared to what right now you think about time series. Next is the reading number 12, measuring returns, volatility, and the correlation. Again, very easy discussion. This is again the repeated discussion. We already discussed majority content of this particular reading in basic statistics itself, but here we are only focusing on the return. So in basic statistics, we focused on mean. Here we are focusing on mean return, like that. Okay, so the concept is same, but we are applying this concept on the returns. So again, you already know like how to calculate the return, how to calculate the continuously compounded return using this particular formula. Again, GAP might test you on this. Okay, then how to convert it into the effective rate, how to convert a continuously compounded return into effective returns, effective annual returns. Then the volatility and the risk measurement, important area. Okay, understand it. Okay, and then there is a specific area which is important here is a time scaling. And one important note, this particular time scaling will be combined with the value at risk discussion in exams. So in exam, if you get a question which requires you to time scaling or the volatility or the value at risk, the discussion relates to this. But what I did, I also mentioned, so our war discussion starts like this only. Now moving on. So sorry for that pause. Okay, now here this discussion will be combined with the like volatility. In volatility as well, I have already combined this discussion. I'll just show you the option sensitivity. Just a second. So see this is our first reading, and first reading starts with the your value at risk introduction and calculation of value at risk, non-parametric approach, how it works, parametric approach, how it works. Then time and confidence interval adjustment. This is specifically provided in this calculation. So that discussion which we just saw in the book 2 relates to this particular part. Okay, so we will be using that discussion with here time adjustment. Okay, so how the time adjustments are done, how the confidence interval adjustments are done, and like that. Okay, now next is the implied volatility. What is the implied volatility? Again, this relates to your book number 4 BSM chapter. Okay, read this section after reading BSM reading from book 4, because we use BSM model for the implied volatility calculation. And as I told you before on the YouTube, like there is a problem with the GAP curriculums, like the way it is structured, because in book number 2 you are studying about implied volatility, which is calculated using the BSM model, and you are studying BSM model in the second last chapter of your curriculum. So that makes like things very complicated. So I specifically provided like you have to read this section after book number 4, reading that particular topic. Now the distribution of financial returns, how it's distributed. So JB test, important. I don't think like calculation is very important. The decision rule is very important. You have to understand a decision rule. If GAP provides you this very specific values, direct values in the examination, so you should be able to answer it. Then the power law is here. Just read all the power laws and all. Now, very favorite area of GAP, if you consider the previous examinations, is Spearman's correlation and the Kendall-Stau correlation coefficient. You must remember how to calculate, or you must know how to calculate all these things. You must understand like when to use the Spearman's or when to use the Kendall-Stau correlation coefficient. Okay, now what type of question can be asked? So first, for the Spearman's correlation coefficient, direct question. Okay, there is no variation possible. So straight, like information is provided, you have to calculate the information or calculate that particular correlation, Spearman's correlation. Now in the Kendall-Stau, there is a possibility. Now what is the possibility here? First, you might get a question where you are already provided with the number of concordant pairs and discordant pairs, and you have to simply calculate the correlation, Kendall-Stau correlation. Second possibility is GAP will provide you a complete table, concordant pairs, but say this particular pair is missing. There is dash, this pair is not provided, and say, just assume this pair is not provided. So these two pairs are not provided, and GAP will ask you what are the missing pairs in concordant and discordant. So option A, B, C, concordant pair, this pair, discordant pair, this pair, and there are 4 combinations, and you have to take the right combination. So that's also possible. So you must remember how to write the pair. Writing pair is very important. Okay. Now next is the reading number 13, simulation and the bootstrapping. Very generalized kind of reading where you can get tested on the any area, but the majority you have to basically understand what is this, what are the concepts here, and all the important areas or the important points. So this reading starts with the introduction of the Monte Carlo simulation, and this is the stock data, simulated data, and tier 2 and all like that. This is based on the actual simulation. Yeah, like this. Then pseudo random number generator, understand what is pseudo random PRNG. Okay, so it is difficult to sell, kind of tongue twister. Okay, now what is seed value, importance of seed value when you have to use seed value like this. Then improving accuracy of simulation like that. Then antithetic variate and how it's used to improve the accuracy. And then there is second measure, which is a control variate. Understand what is like antithetic and what is a control variate and how it works. There is slight difference between the two. Limitations of the simulation. So these are the limitations. Then bootstrapping, how bootstrapping works and how circular block bootstrap works. Again, theoretical question can be asked on this area. Now, bootstrapping method can be ineffective in following cases. So these are the two cases where bootstrapping is ineffective. You have to understand that. Then disadvantages of the simulation, unreliable DGB, data generation process, and simulation. The computational cost is very important, but in based on the evolution happened in the computers or the computational power, this particular part is not that important. Okay, so this is very easy. So that's all the discussion of our book number 2, Quants. See you in the next video. If you like this video, like, share, and subscribe. Thank you, everyone.